You know that feeling when you're trying to browse a website and the scrolling just feels sticky, a bit clunky?
Yeah, yeah. Like you're fighting against it somehow.
Exactly. We've all been there just wishing for that buttery smooth glide as we navigate through a page.
Yeah. That little bit of resistance, it can really detract from the whole experience, can it? It's kind of fascinating how a seemingly small detail, like scroll behavior, has such a big impact.
Absolutely. And that's precisely what we're diving into today. We've been digging through the documentation specifically from the GitHub repository of this neat little JavaScript library called Lenis.
Lenis, yeah. Appropriately named, as we found out. It comes from the Latin word for smooth.
Makes sense.
And it's all about, eliminating that digital friction we were just talking about.
Exactly. And this isn't just some simple hack. The documentation, it reveals a really well-engineered, lightweight JavaScript library. It's designed specifically to deliver that seamless scrolling experience we're often looking for.
Right. And the GitHub repo, that's really the definitive guide here. It details, well, everything from the initial setup to the real nitty-gritty of customization.
So our goal today is basically to unpack all that information for you. We want to extract the essential knowledge about what Linus is, how it achieves that smooth feel.
And maybe why it might be the solution to those jerky scrolls, yeah. All without getting totally lost in, overly technical jargon.
Think of us as your guides, maybe, navigating the tech docs together.
Sounds good.
Okay, so let's get right to it. What is Linus at its core? We know it makes scrolling smooth, but what's the underlying idea?
Well, beyond the name, which is pretty fitting, the documentation immediately highlights a few key aspects. It's designed to be lightweight.
Which is crucial, right, for keeping websites fast.
Absolutely critical. It's also described as robust, so suggesting it can handle various scrolling scenarios reliably. And performant.
Performant meaning it does its job efficiently without, slowing everything else down.
Exactly. Think of it as a finely tuned engine just for your scrolling. It's not going to be a drag on resources.
Right, because nobody wants smooth scrolling that makes the rest of the site lag. And it sounds like it's built for modern web experiences. The documentation even teases some compelling use cases.
Indeed. It points to applications like syncing scroll with WebGL animations. Imagine interactive 3D graphics moving perfectly in sync with your scrolling.
Wow, okay.
And then there's the parallax effect, creating that appealing sense of depth as different layers moves at slightly different speeds.
Yeah, I've seen that. It can look really slick.
It can. And the demo and showcase section linked in the GitHub repo really illustrates these possibilities in action. It's worth checking out.
That sounds really powerful. So if someone's listening and thinking, okay, this smooth scrolling sounds great, how do I actually get it working on my site? Oh, what does the documentation say about getting started? Is it complicated?
Actually, the setup seems quite straightforward. As you probably expect, in modern web dev, they provide a couple of main installation routes. If you're using a package manager, like NPM, the command is as simple as npm ilinus. That just pulls the library right into your project's ecosystem.
Nice and tidy for developers already using NPM or Yarn. What about someone who's less familiar with those tools, or maybe just wants a quick test?
Yeah, they haven't left anyone out. You can also include Linus directly in your HTML. Just use a standard script tag that points to a publicly hosted version of the library.
Like a CDN link.
Exactly. The specific one they give is https.enunpkg.com/Linus at 1.2.3 So that's a really quick and easy way to integrate it into your page.
Okay, so the library's included one way or another. Now, how do we actually tell it to? Well, start smoothing the scroll. What's the JavaScript part?
That involves a little bit of JS initialization. The basic example of the documentation is pretty simple. const Linus, new Linus, autoref.
Okay, let's unpack that a bit. Const Linus, new Linus, that creates the instance. But what's the deal with autoref? What's ref?
Yeah. RAF stands for Request Animation Frame. That's essentially the built-in mechanism for creating smooth animations. It synchronizes with the screen refresh rate.
Right, so it's efficient.
Very. So setting autoref to true tells Linus to automatically hook into this system. It ensures that the scroll position is updated smoothly on each animation frame. Think of it as Linus automatically engaging the browser's smooth animation engine for you.
Got it. Automatic smooth updates make sense. But the docs also mention a custom RAF loop as an alternative. When would someone need that? Sounds more involved.
It is a bit more advanced. You might need it in scenarios where you want really granular control over the animation timing. For example, maybe you're integrating Linus with other animation libraries like GSAP and need to synchronize their update cycles precisely.
Okay.
Or if you have very specific performance optimization needs. The documentation shows initializing lenis without autoref, and then you have to manually call lenis.raftime within your own request animation frame loop.
So it's for those who really want to be the conductor of their whole animation orchestra, controlling every beat.
Exactly. For most standard use cases, autoref true is probably the way to go.
That makes sense for more complex setups. Now, the documentation also emphasizes recommended CSS. That's not always a prominent part of JavaScript library setups. Why is CSS so important for Linux?
That's a good point. Lenis essentially takes over the browser's default scrolling behavior, right?
Right.
And to do this effectively and consistently across different browsers, it often needs to apply specific CSS rules. The documentation suggests a few ways. Either importing a style sheet directly in your JavaScript.
Like import lenis.css.
Yep. Or linking to it via a link tag from a CDN, similar to how you'd include the script. Or even manually incorporating the styles from the Lenis CSS file into your own CSS bundle.
And what does this CSS actually do?
It likely handles things like hiding the native scroll bars, maybe setting up the foundational styles that Lenis relies on to perform its smooth scrolling magic. It ensures the visual aspect matches the JavaScript behavior.
So it's a collaborative effort between the JavaScript and the CSS to create that seamless feel.
Got it. Now, something that jumped out at me in the setup was the mention of GSAP scroll trigger.
Ah, yes.
GSE.
For those who might not know, GSAP is a really popular JavaScript animation library. How does Linux work together with something like scroll trigger?
This is where things can get really dynamic. GSAP's scroll trigger is a fantastic tool for creating animations that are, well, triggered and controlled by scrolling. Think animations firing as you scroll past certain points.
Okay.
Now, since Linux is managing the scroll in its own smooth, non-standard way, scroll trigger needs to be kept informed about Linus's smooth scrolling updates. Otherwise, they'd be out of sync.
Right. The animations wouldn't match the perceived scroll position, so they need to communicate.
Exactly. The documentation provides clear instructions on how to synchronize them. First, you initialize Linus as usual. Then you listen for Linus's on-scroll event.
Okay.
And whenever that event fires, you tell scroll trigger to update itself. The code is basically linus.on scroll trigger.update.
Simple enough. So scroll trigger is kept in the loop about Linus's activity.
Precisely. This ensures that your scroll-driven animations stay perfectly aligned with the smooth scrolling provided by Linus.
Okay, that makes sense. What about the other piece of code mentioned for GSAP integration? Adding Linus's raf to GSAP's ticker. That sounds a bit more technical. GSAP.ticker.add.
Yeah, that one's about ensuring the absolute smoothest possible animation rendering when both libraries are working together. GSAP has its own internal animation loop, they call it a ticker.
Okay.
By adding Linus's raf function to GSAP's ticker using gsap.ticker.add, you're essentially instructing GSAP to use Linus's optimized smooth scrolling update mechanism as part of its own animation rendering process.
Ah, so they share the same timing heartbeat, sort of.
Pretty much. Notice the time 1000 part that's just converting GSAP's time in seconds to milliseconds, which Linus's raf function expects. It's like getting Linus's smooth engine to directly power GSAP's animations for ultimate sync.
And the last line there, disabling lag smoothing in GSAP gsap.ticker.lag smoothing 0. Why is that important when we're using Linus? Isn't lag smoothing usually good?
It can be, yeah. Lag smoothing in GSAP is a built-in feature to help compensate for inconsistent frame rates from the browser. However, when you're using Linus, which is already designed to handle scrolling updates consistently and smoothly.
GSAP trying to also smooth things out might actually cause problems.
Exactly. It could actually introduce unwanted delays or visual hiccups, like a slight stutter. So, disabling GSAP's lag smoothing ensures a more direct and responsive connection between the scroll input, handled smoothly by Linus, and your GSAP-powered animations.
Okay, so combining Linus and GSAP scroll trigger like this lets developers create some incredibly engaging and interactive scroll-based experiences. That's pretty cool.
Definitely opens up a lot of creative possibilities.
Now, let's dive into how we can customize Linus itself. The documentation has a dedicated settings section. What are some of the key settings there that our listeners should know about?
Right, there's a comprehensive set of settings that allow you to really fine-tune the scrolling experience. Starting with the basics, you've got wrapper.
Wrapper?
Yeah, wrapper. It lets you specify which HTML element should act as the main scroll container. By default, it's the window, the whole browser window.
But you could target a specific div.
Exactly. If your scrollable content is just within a contained section of the page, you'd set the wrapper to that div. And similarly, content defines the element inside the wrapper that actually holds all the scrollable stuff. often a direct child of the wrapper.
Okay, so if I have like a single scrolling panel within an otherwise static page, I'd use these settings to tell Linus exactly where that scrolling area is.
Precisely. Then there's smooth wheel. That's a simple true-false toggle. Basically, do you want the smooth scrolling effect for mouse wheel events, yes or no? Defaults to true.
Easy enough.
The lerp setting is particularly interesting, LERP. It controls the intensity of the smooth scrolling through linear interpolation.
Linear interpolation.
Okay. Think of it as how quickly the displayed scroll position catches up to the actual target scroll position. It's a value between 0 and 1. A lower value means slower, smoother, maybe more floaty catching up. A higher value is quicker, snappier.
And the docs mention if you define lerp, then duration and easing become irrelevant.
That's right, because lerp directly governs that continuous smoothing factor on every frame. It's a constant interpolation. So think of lerp as a direct dial for that smooth, almost magnetic feel to your scrolling.
Okay, so lerp gives a more immediate, continuous control over that smooth catch-up feel. What about duration and easing then? When would I use those instead?
You'd use those if you don't define lerp. They offer a different approach to smoothness. Duration sets the length of the scroll animation in seconds. So how long does it take to scroll from A to B when you flick the wheel or use scroll toe? Default is 1.2 seconds, apparently.
Okay, fixed time.
And easing lets you specify the acceleration and deceleration curve of that animation over the set duration. The default easing is a custom function they provide, but the docs helpfully mention you can plug in any standard easing function, maybe from a site like easings.net.
Ah, so you could have it start fast and slow down gently or ease in and out.
Exactly. You get more artistic control over the curve and timing of the scroll animation itself, rather than the continuous interpolation feel of lerp. If you want a more defined, elegant deceleration over a specific time, that's where duration and easing come in.
Ah, okay, so it's really an either direct interpolation with lerp for that continuous catch-up or a defined animation curve with the duration and easing. That makes sense. What other key settings should we be aware of?
Well, orientation is straightforward. Is the primary scrolling direction vertical or horizontal? Default is vertical.
Right.
There's also gesture orientation, which is specifically for touch gestures. It defines a loud scrolling direction can be vertical, horizontal, or even both.
So you could have horizontal scrolling on desktop, but allow vertical touch swipes on mobile, for instance.
Potentially, yeah. Then you have the wheel multiplier and touch multiplier settings. These allow you to adjust the sensitivity, basically the speed, of scrolling with the mouse wheel or touch events, respectively.
Ah, so if the default scroll speed feels too fast or too slow, these are the knobs you'd turn.
Those are the ones. Very useful for fine-tuning the responsiveness.
What else stands out?
The infinite setting is quite interesting. Setting it to true enables continuous looping scrolling, like a carousel effect maybe.
How neat.
Though the docs note it requires sync touch, true, to be enabled on touch devices for it to function correctly there. Something to remember.
Okay.
There's also auto resize, which defaults to true. It uses something called the Resize Observer API to automatically recalculate Linus's internal dimensions and scroll limits whenever the window size changes.
So it adapts automatically if the browser is resized.
Usually, yes. You can disable this by setting it to false and then manually trigger a resize method if you need really specific control, perhaps if content changes size dynamically without a window resize.
Gotcha. Now, the prevent setting sounds particularly useful for complex layouts. It's described as a function that lets you define which elements should not have smooth scrolling applied to them. The example given is a cookie modal.
Right, that's a prime example of enhancing user experience, isn't it?
How so?
Well, imagine you have a modal window pop up, maybe with its own terms and conditions text that needs to scroll. You generally want that scrolling inside the modal to behave normally, natively, right?
Yeah, you don't want the whole page trying to smoothly scroll when you're just trying to scroll the modal content.
Exactly.
Yeah.
The prevent function allows you to define specific conditions in their cookie modal example. It checks if an element has the class cookie modal to tell Linus, hey, ignore scrolling that happens on this specific element or its children. It's about creating intuitive and isolated scrolling contexts.
That's a really clever way to handle those nested scrolling scenarios. The documentation also mentions some HTML attributes like data Linus prevent wheel, and data Linus prevent touch. Are these related?
Yes, they seem like an even more direct way to achieve the same outcome, but right in your HTML.
So instead of writing a JavaScript function,
you can simply add, say, data Linus prevent as an attribute to a specific HTML element, like that modal container div. and Linus will just know to leave the scrolling alone for that element entirely. Or you could use data Linus prevent wheel to only prevent smooth scrolling for mouse wheel events on that element, but maybe allow smooth touch scrolling.
Ah, so it offers a more declarative approach right there in the markup. That's handy.
Definitely.
Yeah.
Gives you options depending on your preference or the complexity.
Okay, moving on from settings. After that, the documentation lists a number of properties that Linus exposes. What kind of information can we access through these? Are these like read-only values?
Yeah, mostly. These properties provide real-time data about the current state of the Linus instance. For example, animated scroll.
Animated scroll.
It represents the current smooth scroll position as calculated and animated by Linus. There's also actual scroll, which reflects the browser's raw underlying scroll position, which might be slightly ahead if the animation is catching up.
Okay, useful for debugging maybe?
Could be. Dimensions gives you information about the scroll container and content size. Direction indicates whether the user is currently scrolling up or down, or left-right, giving you a 1 or -1 value.
Oh, that scroll direction property could be really handy. You could use it to like reveal a sticky navigation header only when scrolling up or change other UI elements.
Absolutely, lots of potential for dynamic effects there. Then there's e-scrolling.
Is it just true or false?
It's actually a getter that tells you if a scroll animation is currently in progress, but also whether it's a smooth scroll initiated by Linus or a native browser scroll, like if Linus is prevented on an element. If nothing's happening, it's false.
Okay, more detailed than just true false.
Yeah. Yep. Limit provides the maximum scrollable value, so the bottommost point. And progress is really useful. It gives you a normalized value between 0 and 1, indicating how far through the scrollable content the user has scrolled. 0 is the top, 1 is the bottom.
Progress bar animations.
Exactly. You also have access to the current scroll velocity, and a Boolean is stopped, indicating whether the Linus instance is currently paused via the stop method.
So a comprehensive dashboard of the current scroll status, basically. Then we have the methods. These are actions we can tell the Linus instance to perform, right?
Correct. These are functions you call in the Linus instance.
And the scroll to method looks like a central one. It seems really flexible. What can we do with that?
Scroll to is the programmatic way to make the page scroll somewhere specific. And yeah, it's incredibly flexible. The target, the place you want to scroll to, can be given in several ways.
Right.
You can provide a specific pixel value, like lenis.scroll to 500, or a CSS selector string, like lenis.scroll to, hashtag section 3. Yeah. Or lenis.scroll to.contact-form.
So it finds the element and scrolls to it.
Yes. Or you can use predefined keywords like top, bottom, start, or end, and you can even pass a direct reference to an HTML element object as the target.
Wow. Okay. Lots of ways to specify destination. And it takes an options object, too, for further customization, right?
It does. The options allow for a very fine-grained control over how that scroll animation happens. You can specify an offset, similar to CSS scroll padding, maybe to account for a fixed header.
Ah, so it doesn't scroll right to the element edge, but leaves space.
Exactly. You can also override the global lerp, duration, and easing settings just for this specific scroll to action. So you could have generally smooth site, but one specific button triggers a really fast immediate scroll.
Nice.
You can set immediate true to make the scroll happen instantly with no animation at all. You can lock the scroll interaction, preventing the user from interrupting the scroll until the target is reached.
Ooh, locking could be useful sometimes.
Maybe. You can force the scroll to happen even if Linus is currently stopped via the stop method. And importantly, you can define an onComplete callback function.
So do something after the scroll finishes.
Precisely. A function that will execute once the scrolling animation to the target is finished. You can also pass along some user data in the options, which then gets included in the scroll events triggered by this specific method call. Useful for tracking, perhaps.
That's an impressive level of control for just one method. What about the other methods listed? Stop, start, resize, and destroy. Their names seem fairly self-explanatory.
They're pretty intuitive, yeah. Stop. Pauses any ongoing smooth scrolling animation and prevents new ones from starting via user input.
Like hitting the brakes.
Kind of. Start resumes it. Resize is crucial, as we mentioned, if you have auto-resize disabled or if the layout of your page changes dynamically in a way that Linus might not automatically detect, like loading in new content. Calling resize manually recalculates the internal dimensions and ensures accurate smooth scrolling continues.
So you tell it, hey, things changed, measure again.
Exactly. And destroy does what it says. It completely removes the Linus instance, cleans up any associated event listeners, and stops all functionality. Essential for cleanup, especially in single-page applications, or when you're dynamically adding and removing lenis functionality on parts of your website.
Good resource management. Now, to really understand what's happening under the hood, the event section seems key. What kind of events does Linus dispatch that we can listen for, like we mentioned with the GSAP integration?
Right. There are two primary events documented, scroll and virtual scroll. The scroll event is the main one you'd likely use.
Okay.
It's fired continuously whenever the smooth scroll position changes. And the callback function you attach to this event receives the lenis instance itself as an argument.
Oh, so inside the event handler, you have access to all those properties like progress and velocity.
Exactly. Makes it easy to react to the scroll state, lenis.onScroll, ns.log, for example.
Nice. What about virtual scroll? Sounds lower level.
It is. The virtual scroll event fires in response to the raw input events, like mouse wheel or touch move, before lenis applies its smoothing. It provides you with the raw delta-x and delta values of the scroll input, as well as the original browser event object, wheel, touch move, etc.
So what's the use case for that?
It could be useful for more advanced integrations, maybe if you're building your own custom scroll-based interactions where you need the raw immediate input data before the smoothing kicks in, or maybe for some complex synchronization tasks.
Okay, so virtual scroll gives you the direct input data, while scroll provides the more processed, smooth view within the context of Linus's animation. That makes sense for different levels of interaction needed.
Yep, covers both bases.
Now we arrive at the considerations and limitations sections. These are always important to understand before jumping in with any new technology. Let's start with nested scroll. This is a classic challenge, right? Having scrollable elements inside a larger scrollable page. How does Linus approach this?
Yeah. Nested scrolling can be tricky. As we touched on earlier with the prevent setting and those data Linus prevent attributes, Linus provides specific mechanisms to basically tell it, hands off this element.
So you explicitly exclude the inner scrollable part.
Exactly. The documentation highlights both ways. The JavaScript approach, using the prevent function during Linus initialization, where you define some logic to identify nested scroll containers, like if this element has overflowy.scroll.
Or the HTML attribute approach.
Right. Using data Linus prevent or its variations, which is often simpler and more direct, just tag the element in the HTML. The key is to selectively apply Linus's smooth scrolling only to the main scrollable area, often the body or a main wrapper, and allow those inner scrollable elements like text areas or modals to behave with their normal native browser scrolling.
So it's about being selective and preventing Linus from interfering where it shouldn't. Makes sense. What about anchor links? Links like a href, hashtag section 2, those are fundamental for website navigation. Does Linus handle these okay?
Good question. By default, because Linus is intercepting scroll behavior, it might interfere with the browser's usual instant jump for anchor links.
Ah, so they might not work out of the box.
Potentially not smoothly, or maybe not at all, depending on the setup. So the documentation explicitly states that you need to enable the anchors, true option during Linus initialization.
Okay, so just flip a switch.
Pretty much. And furthermore, you can provide a scroll to options object to the anchor setting instead of just true. This lets you customize the anchor scrolling behavior using those same options we discussed for the scroll to method.
Like adding an offset.
Exactly. That's a key use case. Adding an offset to account for sticky fixed navigation headers that might otherwise obscure the content you just scrolled to. Or maybe you want a specific duration or easing just for anchor link scrolls, or an incomplete callback.
So good to know that anchor links are not only supported, but can also be further refined with those scroll to options. Very useful.
Definitely addresses a common need.
Now, the limitations section. Always crucial for setting realistic expectations. What are some of the key things Linus doesn't handle natively, or where it might have some quirks?
One significant limitation they call out is that Linus doesn't have built-in support for CSS scroll snap, where content snaps into place as you scroll.
Right, that's a popular CSS feature now.
It is. If you're relying on that kind of snapping behavior for your layout, the standard Linus library won't automatically work with it. The documentation directs you to a separate optional package called lenis.snap that you would need to integrate alongside the core Linus library to get that functionality.
Okay, so it's possible, but needs an extra piece. Good to know. What else?
There are also some browser-specific performance things mentioned. For instance, Safari on macOS apparently has a performance cap, limiting animations like this to 60 frames per second, even on high refresh rate monitors. And it drops to 30 fps when the device is in low power mode.
Ah, so the smoothness might vary slightly depending on the user's browser and power settings. Important performance nuances to keep in mind.
Definitely. What else? Ah, iframes. Smooth scrolling won't function across iframes because technically if frames don't forward wheel events up to the parent document where Linus would be running.
Okay, so embedding content that needs smooth scroll within an iframe won't work seamlessly with the parent page's Linus instance.
Correct. There's also a mention of potential lag issues, specifically with elements using position. Fixed, but only on older macOS versions of Safari, apparently pre-M1 chips. Seems like a specific browser rendering quirk.
Edge case. But good to be aware of if supporting older Macs.
And one more on touch.
Yeah.
They note that touch events might exhibit unexpected behavior when the Sync Touch option is enabled, but specifically on older iOS versions below iOS 16.
Okay.
And finally, just reiterating what we discussed about nested scrolling, if you don't configure it properly using prevent or the data attributes, you can definitely get unexpected or conflicting scroll behaviors.
Right, so proper setup is key there. It sounds like, like any powerful tool, Linus has its boundaries and potential edge cases, depending on the specific implementation and the browser environment.
That's a fair summary, yeah.
The troubleshooting tips seem like the next logical stop for when things, inevitably perhaps, might not be working as anticipated. What guidance does the documentation offer for debugging?
They offer some solid practical steps. First and foremost, always make sure you're using the latest version of Linus. Obvious, maybe, but crucial as bug fixes and improvements are always being released.
Keep it updated. Makes sense.
They also strongly emphasize the importance of including the recommended CSS. They state that missing or incorrect CSS is a very common source of issues. So double check that CSS import or link.
Right, the CSS is not optional for proper function.
Definitely not.
Oh.
Then, a really helpful diagnostic step they suggest is to temporarily remove any integrations, like QSAP scroll trigger, and even Linus itself entirely for a moment,
Why is that?
to verify if the underlying page or the specific element you're working with is actually scrollable in the first place, using just the browser's native scrolling. Sometimes the issue isn't Linus, but the basic HTML CSS structure preventing scroll.
Isolate the problem. Good thinking.
And lastly, they remind users to double-check that they have either the autoref true option enabled during initialization, or if they're using a custom loop, that they are definitely calling lenis.darkroom.engineering correctly within that loop. Because without that regular update call, the smooth scrolling simply won't happen.
Solid practical steps for diagnosing potential problems. Seems like a good checklist. Now, for those who are intrigued and looking to delve deeper, maybe see Linus in action or extend its capabilities, the documentation points to sections like tutorials, plugins, and a Linus in use showcase. What can we find there?
Yeah, these look like great resources. The tutorial section provides links to external articles and guides. They mention some insightful articles from code drops, exploring scroll animation concepts, and even specific techniques like animating SVG shapes based on scroll.
CodeDrafts always has cool stuff.
They do, and there are also practical Webflow tutorials mentioned, demonstrating how to integrate Linus within the Webflow platform, and specifically, how to use it alongside GSAP scroll trigger in a Webflow context.
So fantastic for seeing real-world applications and getting practical implementation knowledge beyond just the core docs.
Exactly. Then the plugins section lists some community-developed extensions that add even more functionality. There's one mentioned, R3F Scroll Rig, for seamless integration with React 3 Fiber, if you're doing 3D stuff in React.
Okay, extending its reach.
Interestingly, they also list Locomotive Scroll there. It's worth noting that Locomotive Scroll is actually a separate, well-known smooth scrolling library itself, maybe more feature-heavy than Linus. Perhaps it's listed for comparison, or maybe there are ways people integrate parts of them unclear from just the list.
Interesting inclusion. Good to see an ecosystem potentially growing around Linus, though, with extensions and learning resources. And the Linus in Use section sounds like an excellent place to get inspiration, right? See what's possible, what kind of websites are featured there.
Yeah, the showcase features a really diverse range of websites. You've got creative agency portfolios, like Studio Freight is mentioned, probably highlighting smooth navigation and subtle interface animations.
Polished feel.
Then more interactive digital experiences, like something called Sculpting Harmony by Rez, likely demonstrating more advanced scroll synced effects. And even websites for product presentations, like Daylight Computer is listed, showcasing how smooth scrolling can enhance the user experience when you're trying to showcase a physical product online.
So it really illustrates the versatility of Linus, huh? Improving user interaction across all sorts of different types of online content.
Definitely seems that way. It's not just for one niche.
Finally, let's just quickly touch on the license and community aspects. The documentation mentions the MIP license. What does that mean for developers considering using Linus in their projects?
The MIT license is great news for developers. It's a very permissive open source license. Generally, it grants developers extensive freedom to use, modify, and distribute the software, even in commercial projects with very few restrictions.
What's the catch? Usually there's something.
The main requirement really is just that they include the original copyright notice and the license text somewhere in their project. It's designed to encourage broad adoption and collaboration, not hinder it.
That's great for flexibility and definitely encourages widespread use. And regarding the community around Linus, what does the GitHub page indicate? Does it seem active?
Oh yeah. The repository statistics mentioned in the source, and which you can see on GitHub, speak volumes. It mentions having like over 10,000 stars, hundreds of forks, hundreds of watchers.
Wow, those are solid numbers.
They really are. It's clear that there is a significant and active community surrounding Linus. And the fact that there are also multiple contributors listed indicates that it's not just one person's project. It's an evolving library with ongoing development and community support baked in.
That's reassuring.
They also provide a link for sponsoring the project, which is a nice touch. A way for companies or individuals who find Linus valuable to directly support its continued development and maintenance.
So it's not just some obscure tool, but something that's gaining significant traction and has a supportive community behind it. That's good to know. All right, we've covered a huge amount of information here, really diving deep into the Linus documentation from GitHub. What would you say are the core takeaways for someone listening who's maybe thinking, okay, should I look into this for my next project?
Yeah, to boil it down, I'd say the key takeaway is that Linus offers a really robust, yet remarkably lightweight solution for significantly enhancing the feel and interactivity of website scrolling. It goes way beyond the basic browser scrolling by providing these highly customizable, smooth animations.
And all those settings we talked about.
Exactly, and that comprehensive set of settings to tailor the experience precisely. Plus, its seamless compatibility with powerful animation tools like GSEP Scroll Trigger just unlocks a world of possibilities for creating truly engaging and dynamic scroll-driven narratives or interactions.
And for you, the listener, understanding and maybe implementing something like Linus can be a real game changer in elevating the user experience on your websites or web applications. That smooth scrolling, it can contribute to a more polished, modern, and ultimately just a more enjoyable browsing experience.
Which often leads to increased user engagement, maybe better retention, and just a more positive perception of your content or brand overall. Little details can matter a lot.
Definitely. So if you're intrigued by these possibilities, what's the next step?
Well, the obvious next step is to actually head over to the Linus GitHub repository yourself. Dive into the complete documentation we've been discussing, check out the interactive demos they have, see it and feel it in action firsthand.
Yeah, try it out.
And start considering how you might integrate it into your own projects or areas of interest. And don't forget those linked tutorials in the Linus in Use showcase. They're invaluable resources for gaining practical ideas and seeing real-world implementations before you commit.
Great advice. And on that note, here's a final thought maybe to ponder as we wrap up. In the broader landscape of web interaction, okay, smooth scrolling might initially seem like a subtle refinement, maybe just aesthetics. But what other seemingly small animations or, nuanced design choices could actually have a surprisingly profound impact on how we experience and connect with digital content? Think about those often overlooked details. They might just hold the key to crafting truly intuitive, maybe even delightful online experiences down the road. What's the next smooth scroll?